This video will discuss the significant figure rules for determining how many digits you should display in the answer of an addition or subtraction calculation. So when adding or subtracting numbers, the result goes to the same number or same decimal place as the number with the fewest decimal places. So we're no longer counting how many digits, we're counting which decimal place or which position the number ends in. So this one ends 2 digits after the decimal point, this one ends 1 digit after the decimal point. So in my calculator, I'll put in the numbers, I'll write down my answer with pretty much, not in this case everything that's displayed, but just make sure you include a few extra. Okay, so I get a 2.94, and now I need to figure out which of these are significant figures. So this number should go 2 digits after, this number goes 1 digit after. This one has uncertainty of plus or minus 0.1. This one has uncertainty of plus or minus 0.01. We assume plus or minus 1 in the last digit. This is more uncertainty. My answer will go to this uncertainty, so it will end in the first digit after the decimal point because that's the first number to end here. That's 0 to 4, so 2.9. Now one way you'll see this drawn is by writing the numbers lining up the decimal point. And this is convenient for letting you visually see that that 9.7 ends with more uncertainty than the 12.64, and so my answer should go to that digit. It won't always be practical to write it out this way, but perhaps this lets you see what's going on. But this ends 2 digits after, this ends 1 digit after. This is more uncertainty. 2.9 is my answer. Okay, so let's do this one. So I'm going to do 4,200 plus 182.6. And my calculator gives me 4,382.6. I now need to figure out uncertain digits. So this one, those trailing zeros aren't significant with no decimal point, ends in the hundreds place. So 3 to the left. This one ends 1 to the right in the tenths place. Plus or minus 100 is much larger than plus or minus 0.1. So this will determine the uncertainty in my answer in the hundredths place. This is 5 or more, so my answer will be 4,400. You need to put these zeros on there when you round that number because 44 is not the same as 4,400. Okay, so when you eliminate zeros to the left of a decimal point, or eliminate digits to the left of the decimal point, you replace them with zeros. With the right, you just drop them. Okay, 1.224 plus 18.722 plus 0.1174. Those were all pluses. So I get 20.0634. This goes to 3 digits after the decimal point. 3 digits after the decimal point, 4. So 0.001 is larger than 0.0001. So we're going to end in that 3 digits after the decimal point. These numbers end first before that one. So my answer should be 20.063. Okay, if you have units on there, you need to make sure that you're in the same units. And a common issue here is like an SI prefix or something like that. But the units must be the same to do a subtraction. 763.1, in this case they are, so I don't need to do any conversions before I start. And I'll subtract 25.9. And I will get 737.2. The result will have the same units as the units you subtracted. And then as we look at this, we're not counting 4. We're going 1, 2, 3. Here's the last significant digit, 1 digit after the decimal. Here's the last significant digit, 1 digit after the decimal. My answer should go to 1 digit after the decimal, the least certain digit here, and my answer is 737.2 torr. In this case, my calculator gave me the right answer, but you can't really trust that. Okay, 6.44 plus 9.26, 15.7. This number goes 2 digits after the decimal. This one goes 2 digits after the decimal. So my answer should go 2 digits after the decimal. I don't have anything there. And what's going on here is my calculator drops that trailing zero, so I need to add that back in, 15.70. Now, one thing I glossed over in the first example on the previous page, and I want you to notice here, this has 4 significant figures if I'm counting, and both of my numbers that I put in had 3. When you're adding and subtracting, the number of significant figures can change, but we're looking at where the last significant figure is, where the first uncertain digit is, and that's what we're carrying over to do these calculations. Scientific notation can cause a number of problems and challenges here, because we're not really looking 2 digits after the decimal. Because that's modified, this is going to be different for each of these numbers. And there's a number of ways you can do this. One is you can change them all to the same exponent. So this one we might change to 0.00922. I got that wrong. Just one. And this one would be 0.592, and this one will be 1.83 times, and all of these to the negative 3. Okay, another one is you could write them all out in decimal notation and look at it that way. I'm going to explain a slightly different procedure that I like doing that's easiest for me in these, and I'm going to start by looking at this previous calculation. So I'm going to label that as 0. This one spot is 10 to the 0. This spot here is 10 to the negative 1. This spot here is 10 to the negative 2. So if I were representing 0.04, it would be 4 times 10 to the negative 2. Okay, and I can apply that on these numbers, but instead of starting as 1 being 10 to the 0, it's 10 to the negative 3 here. So this is negative 3, negative 4, negative 5. This one starts at 10 to the negative 5, so this is negative 6, negative 7. This one is negative 4, negative 5, negative 6. Okay, 10 to the negative 5 is a bigger number than 10 to the negative 7 or 10 to the negative 6, so my answer will end in the 10 to the negative 5 spot. And so if I come over to my calculator, I have 1.83, and don't write out times 10 to the something. Use your exponential notation key. In my case, it's second, and that EE there. And then I put in not minus the negative 3. And I'm going to add 9.22 times 10 to the negative 5 and 5.92 times 10 to the negative 4. And my calculator dumped it out as 0.002514. That should be enough. Okay, so this was 10 to the 0, negative 1, negative 2, negative 3, negative 4, negative 5, 0.00251. You should also know on your calculator how to force it to display in scientific notation. Not a big deal for this number given it's not too small, but on this calculator, if you go second, science and engineering, you can change it to scientific notation, and it will display it as 2.5142 times 10 to the negative 3. Okay, and again, this is the negative 3, negative 4. There's my last significant figure in the negative 5 position. So 2.51 times 10 to the negative 3. And these two numbers are the same. Okay, let's check your understanding. Go ahead and pause the video and solve the problem. So in this case, this is going to the 10 to the negative 4 position. This was 0, negative 1, negative 2, negative 3. This one, we start at 10 to the negative 3, negative 4, negative 5. So my answer will go to the 10 to the negative 4 position, so 0.0962 plus 8.51, and I get 1.0471 times 10 to the negative 1. I want to display this in float notation, so I'll change back to FLO, so 0.10471. These are the same number, just in decimal or in scientific notation. And I wanted to go 4 digits after the decimal point, 1, 2, 3, 4. So 0.1047. D is the correct answer.